Hi, everybody. It's Dr. Sean, the Magic Mon. I'm going to talk to you today really quick about X-ray physics made easy. This is part one. There'll be several parts to this, and just to be totally honest with you, I am not a physicist. I'm a chiropractor, but I'm going to kind of boil down these concepts and just make it easier for you to understand. So here we go. So this is the area we're going to be talking about. It's the X-ray tube, and it has the columnator on there. You've taken x-rays in the past, you know exactly what I'm talking about. You've had x-rays taken on you, you know exactly what I'm talking about. But within that tube itself, we have the x-ray tube. The tube is made of Pyrex glass because when you create x-rays, photons, you make a lot of heat. There's the cathode side right here. Cathode side is negative. Easy way to memorize that is I'm allergic to cats, that's negative. It's negative because this is the area you're making electrons. The anode side is positive, and the reason why it's positive is because it's going to attract the electrons. There's a motor right here that spins the anode. The anode is that tungsten disc, and when it spins, it is dispersing heat because, as I said, the creation of X-rays creates a lot of heat. So it spins to disperse the heat, exposure area, greater area for the focusing. So let's talk more about this. So here's the cathode right here. Here's the anode. So we are going to concentrate on this side first. This is the cathode. So let's talk about what's happening here. The cathode has a focusing cup. What it's going to do is going to focus or concentrate the electrons that we're going to create here in a minute. You have a filament, long filament, short filament. Long filament here is going to be bigger focal spot, shorter focal spot, and they're tungsten coils. We're going to put electricity into here. As electricity flows in there, you increase the resistance. Resistance to that flow will create heat. That heat generated will start to boil off electrons. This is what we call thermionic emissions. Creates a space cloud of electrons around the focusing cup. So once you get enough electrons that you want, which will be Ma, we'll talk about that here later. Once you get enough of those electrons you want in there, you're going to push exposure and you're going to then make the anode positive, and it's going to shoot the electrons across to the anode. So let's draw the anode here. Here's the anode. It is also tungsten. And remember the anode spin. So I'll just go ahead and just put the focusing cup here and the electrons over here. So when you create the exposure, the electrons are going to shoot across. They're going to strike into the rotating anode. As I said earlier, the anode is spinning to disperse the heat. Most of it is going to be heat. But as you strike the anode, what you're going to do is you're going to create photons. The photons are going to go all the way around in 360 degrees. As it goes 360 degrees, the only useful beam is going to be the ones that are going to go through the bottom where the columnator is. The process of creating photons from electrons is using the first law of thermodynamics, which means you can't create energy or get rid of it. It just changes forms. So the electrons fly across, strike the tungsten anode, get released as photons, which are energy. Now, photons, in quantum mechanics, there is the wave-particle duality, which describes how photons act. Because photons act as light, they're traveling light, and photons could act as a particle when it interacts with matter. So photons leave and that's going to be your useful X-ray beam. What's really kind of weird about this whole setup, yet it still works because that's what we use. Out of 100% of the electron energy, we only have 1% of that being the useful beam. Kind of looks inefficient in a way, but that's what we do. All right, quick joke. So a photon goes to a hotel, checks in at the front desk. Bellhop says, do you have any luggage I can carry to your room? And the photon says, no, I'm traveling light. Thank you. I'll be here all week. Tip your servers. Now going back to that rotating anode. As the electrons slam against the rotating anode, we create photons. This is made through what we call Bremsstrahlung radiation. Bremsstrahlung literally translated means breaking. So you're taking an electron and slamming it in, breaking, slowing, and the energy is then released as a photon. 90% of radiation is via Bremsstrahlung. The other 10% is characteristic. This is the creation of photons. We'll talk about more of these concepts in later discussions.